Hello, welcome again. I'm solving the 2025 challenge problems from Everybody Codes many months after they were released, but better late than never, I guess. Today I'm going to be doing quest 15. Time is a little bit tight here, so hopefully this will be one of the ones that takes me closer to half an hour than closer to an hour. I am going to be putting up a video. I'm not quite sure when. I am going to be putting up a video in a little bit of how I was able to take my solution to quest 12 and optimize it quite a bit. I don't know if you remember in quest 12 the solution I had was taking on the order of 12 or 13 seconds, and I got it down to well under 1.5 seconds. I had hoped to get it down under 1 second. I can't quite do that. There might be some really ugly optimization stuff that I could do to get it even further, but I think I'm going to leave it where I got it of just 1.5 seconds. Anyway, I didn't do that on camera, so I'm going to have to create a video later where I go through the changes and explain what I did. Anyway, enough of that. Let's start the timer here and open up quiz 15. Quest 15. Okay, pulsing symbols disappear. Yay! Dragon duck's cheer. Tiles. Tunnel switch. Crash. Some still need help in moving. Wonderful news. Okay. List of instructions says very long wall. Left. One, two, three. Turn right, go 4 more. Turn left, go 3. Go 4 more. Turn right, go 3. The goal is reaching the last segment. Okay. Six seconds. 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So I figure we just create this, we create a grid, then we do a simple breadth first search, or maybe we do Dijkstra, whatever. Okay, so first of all, we only have one scanner dot scan data line text folders strings.split data line split on commas parser must compile LR okay, grid grid will be a map from and then we have a problem here that I haven't defined what a chord is. Type chord struct x comma y int. Okay. For wall thing range parts parser dot find string submatch find string submatch for wall thing then okay, heading is going to be either heading chord -1 comma 0 and then so if okay, and end will be ... Okay, E is the last thing. E is that last thing. Okay. If switch parts 1 0 case L heading equals chord. Okay, if we are turning left, then that will go from -1 0 to 0. So switch that and negate that. So this becomes heading.y, negative heading.y, heading.x, case R, Okay, and then dist conv dot a to I of parts bracket 2 for D for range dist spot equals chord spot dot x plus heading dot x spot dot y plus heading dot y, and then grid spot. Okay. And then when we are done, spot is where we're going to. We're going from 0, 0. Dists colon equals make map make. I say make and then I type map. Chord int dists bracket recent for dists bracket spot equals 0. Grid bracket spot E. Actually, I could just do this. For new recent make for in recent C equals chord B dot X plus J jump.x b.y plus jump.y. If underscore comma already continue this what do I do? New recent, append new recent C dists C equals this dist plus 1. If CH is equal to E, okay, I think that looks good. Let's download the quiz. Let's move the data into place. Go run Quest 15. Okay, what's going on here? Oh. Here what I mean to say is recent equals new recent. 69. Nice. Okay, let us see if this works. No! Damn it. Okay, let's try this one. And let's go up here and let's say data equals byte. Really? Okay, it's doing that regardless of what data is. Is it, okay. Okay, so I feel like I've screwed something up here, but I don't know what. Like, I note that the answer it's giving me, 69, that is what capital E is if you turn it into, from ASCII into a, like 69 is capital E turned there. So spot is now end location. So what I'm going to do here, so how did I screw this up? Okay. Right. Oh. Right, okay. So I think what I need to say here is ready if grid bracket C D. Okay, now this says 5. Okay, now 5 is not correct, but at least we're going to get a better answer here. Print line dists. So what is dists? Okay, so 0, -3. Okay. Okay, so at least that gets the right thing. And one, 2, 3, 4, 5. Okay, now let's copied, paste. Okay, let's try this. 16. Okay. $110. Yep, okay. So, took me a little longer than expected. Walk. Contemplation. Celebrated. Child's name and names of parents inscribed, but in the lands you just saved. New egg in many, many years. These names have a completely different style. No dragon duck. The end of the planned route. stairs in this place, down. There's another puzzle at the bottom of the stairs. Slightly larger. Okay, I mean, yes, I know I probably should be doing some kind of Dijkstra approach. Eventually that's going to get me in trouble, but I'm just going to try to see if I'm just going to try to see if we can just do this way. Four, 3, 3, 1. Yay! Okay. So my long ago. I should have. Endpoint seems to be okay. Same deal. I find it hard to believe that I stumbled upon the right way to do this right away. Okay, this one finally is going to take some time. So, okay, that's running. While that's running, let's go do this, and we're going to move it around so that okay, so our part 2 is just redo part 1. So for problem 3, for part 3, we do the scan the same. We do recent the same, but we then do something else. Now what we want to do is we want to get a heap going. Get the priority heap going. And so for that, I have to go back and I have to look up. Yeah. Golang. Yeah, I have to look up container heap. Okay, insert priority queue. Okay. And then yeah. Okay, so here we go. Heap. And now this will be type heap item struct where chord dist this so far int guess remaining int. And then what I want to do is I want to define type these are locals, type heap item, type search heap it's just a list of heap item func search heap and int return len sh func sh search heap less ij int bool. Okay, we want pop to give us the lowest value. Okay, so sh bracket I return I dot dis so far plus sh bracket I dot guess remaining less than sh bracket j dot dis so far plus sh bracket j dot guess remaining. Swap and then push and pop. Push search push x any. This will be append sh x dot heap item. That's the old length, and then we do retval. No, actually. Oh, right. Actually, okay. There. Okay. Scene. Bool. Actually, scene should be empty initially. And what do we have? We have heap item. And then what do we have here? We have where, which is 0, 0. This so far 0, 0. This so far 0, 0. Okay, and now what we do for okay, now we do heap.init. Heap. Heap.init. What? I have len. I have search heap, type search heap item, search heap len. has pointer receiver. Push. Yeah. Pop has a pointer receiver. Isn't that what we're supposed to do? Okay. Search heap does not enter method pop has pointer receiver. Okay, I'm gonna have to search for that error message because I don't understand. String. Does not implement star search heap does not implement heap.interface. Wrong type. Oh. Yeah. Okay, there we go. Blah. Lovely error messages there go. Okay, so for length that, working heap.pop as heap if seen working heap item working dot where continue seen working dot where becomes true. Am I done by the way here? No, I am not. Yeah, wow. Scene of working where becomes true, then I gotta do for jump here, here, if grid is equal to E, return working dot this so far plus 1. Otherwise, we put it on the heap. Estimate equals x equals c.x minus spot.x. Estimate y estimate equals x less than 0, question mark, negative estimate x, colon estimate x. Seriously? If there has to be a better way to do this in Go. It's just disgusting that there's not a built-in abs function. Anyway, heap dot push ampersand search heap item. Where is C? Dist so far is dist so far plus 1. And then this is estimate x plus estimate y. Okay. Well, even using Dijkstra, this is proving rather difficult. I'm just curious. Let's go see what this looks like. Okay, so I guess then the next thing to see is there a way to do coordinate compression? That's the only thing I can think of. So for coordinate compression, what I'd want is I'd probably want something one on each side of every x and y coordinate. I mean, on the other hand, these things are only in the, they're only in the range of millions. So, okay, well, shoot. Simple, straightforward Dijkstra wasn't enough. We're going to have to implement coordinate compression here. Unfortunately, I don't have time to do that right now. So I'm going to do something a little bit unusual. I am going to stop the timer and stop the recording. And I will be back here when I can spend another half hour to 45 minutes on that. And so when you see me in a little bit, I may be wearing different clothing because I don't know if I will have more time today even to finish this. Okay, and we are back. So, first off, yeah, this still isn't done. It's been hours that I left this to go. So yeah, we're definitely going to have to use coordinate compression. So what is coordinate compression that I'm talking about? It's when you decide, okay, I'm going to determine that that I'm only going to keep track of information at certain coordinates, because the vast majority of the space nothing interesting is happening at. So to really do coordinate compression, I'm going to need two functions. Yeah. Func go up, which takes a which takes a list of A's, takes a val of A and a binary search. Okay. Okay. All vowels, vowel. let's call it, okay, if where okay, if greater than all vowels minus 1, actually wait, if it is real, then we else return all vowels where plus 1. Okay, so this return, so what go up does is you hand go up something that's in the list, and it gives you the next thing in the list. Or if you're all the way there, it gives you back the thing you gave it, because I don't have a better thing to do. Actually, this if Israel would appear in the search array. Okay. Okay, not sure about that. Okay, so target's found. Where can never be less than 0. That's silly. Okay. Down. Okay. So this should always give us the thing that is in the list that is less than where we were. This always gives us the thing that was in the list that is more than where we were. Okay, and why did I do that? Okay, so I'm going to go through these wall things twice. I'm going to make grid here, and this will be real chords map. Now I'm going to do kind of silly compression in that I'm going to compress x and y the same. And here what I'm going to do is I'm going to do dist times dist times dist. Okay, real chords bracket -1 true, real chords 0 is true, real chords 1 is true. Real chords spot.x is true. Y minus 1 plus 1 plus 1 minus 1 plus 1. Okay, so those are all the real chords. And then make int 0 for range real chords map, real chords append, sort real chords. Okay, now grid. Spot 0, 0. Okay, now I go through this again. Oh, it's telling me I can simplify. Now I go through spot again, and I say Okay, reset spot. I gotta reset heading too. If real chords map of spot.x and real chords map of spot.y okay, now ideally I should be using go up or go down to get there. Yeah, I'm going to do this. Heading, chord, 1, 0. Heading is chord 1, 0, then spot.x equals go up go up spot.x and all vowels, real chords. Okay, fine. Case chord -1, 0. Spot.x go down spot.x real chords. Oh, right, because I have to do it this many times. Chord 0, -1 spot.y equals go down spot.y. Um, okay, now. Copy. Switch, jump. Okay, now. Okay, now I'm just doing the regular thing. Okay, so it ran out really fast. Okay, so at here. Okay, so the question I have is, why did it immediately jump there? So I'm questioning my go up and my go down routines because I just wrote them straight, I didn't test them. So let's check out what happens with go down val. 0, 0. Go up. Oh. C, 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 C. Okay. Well, we are certainly doing more than we need to. $71.02. Okay, so let's just try that. 71.02. Nope. Okay. Well, let's try. Let's just see if I have. Let's just see if I have this correct. 54. Okay, so that is very wrong. Okay, so yeah, part of the problem is that we said this so far was that, which it isn't. Okay, so jump size. Actually, jump size minus equals c dot y. Okay, and now here we do jump size. 4331. Okay. Now we do part 3 with the real data. Yay! Okay, and yeah, it took me an hour 21 minutes, but I had a big break in the middle. So yeah. Okay, so let's we can stop that timer. Can close this. Okay, let's clean up some stuff here. Okay. So yeah, that took me a while, and it looks like this whole video is going to be like an hour and a half long, but okay, it works well. So go up and go down, just give me the next thing in the list or the previous thing in the list, just going up or going down. I go through the whole left-right thing once, and I mark the spots, and the spots, right, I mark those as real coordinates, and all of the other coordinates are fake. And those are, then I go through and I do the grid, and I only mark down the grid at the real coordinates. And then, because all of the coordinates in between the real coordinates I declare as fake. Then here I have this jump, and I've got to go up and down by the right amount. And yeah, make sure I have my jump size correct instead of just saying that we're always going by one. I think I called this Dijkstra several times as I was talking. I mean, it's really a star because I'm including an estimate. They're basically the same algorithm. But yeah. So I still have this. I'm vaguely surprised this doesn't reformat into something nicer automatically, but yeah, and with the coordinate compression, I might not even need to use the heap stuff at all. With the coordinate compression, I might be able to just do I might be able to just do the simple breadth first search that I did before, suitably modified to only touch real coordinates and to always have, like, you know, to always calculate the jump size and do that. But this is fine. Okay, code cleanup, commit the code. Yeah, quiz 15. Push the code up. Okay, thank you for watching, and I will be back later this week with at least one quest, and we'll see how those go. Thanks.